So, today we're going to be talking about bridges, and what type of engineer would work on a bridge? Gabby? Good.
The best time.
So just some basic vocabulary to understand before we get into the actual lesson is span. It's the distance between the supports that we're using on the bridge. It's not how far the bridge actually goes, okay? It's distance between supports. Force, pushing force, compression. So we all take our hands like this, flat, push them together. We got a compression. Take our hands like this, lock our fingers, pull apart. That's tension. This is a pulling force. These are basically how we understand the forces inside of a bridge so we can make them hold things up.
Alright, so there's 4 types of bridges that we're going to talk to you about today. First we have a beam bridge, next we have an arch bridge, then a suspension bridge or a cable stay bridge that are really closely related, and then we have a truss bridge. So the very first type we have is a beam bridge, and a beam bridge is basically a rigid beam with piers attached to it. So we have a flat surface, which is going to be like a roadway, and then we have vertical piers that occur every so often, and these have spans up to 250 feet, so not very far, almost the length of a football field, and the larger that distance between those piers, the weaker the bridge becomes. So here we have a very simple example of a beam bridge. We can see the straight beam going horizontally, and then we have vertical piers that help support the bridge. And they can get really complex, so a lot of road systems that we use actually use beam bridges for that application.
Next we have arch bridges. An arch is sort of a rainbow shape, okay? In this shape, it wants to lean in on itself, so it's kind of holding itself up. It's a really strong natural shape. Spans up to 800 feet. So again, 800 feet between piers or supports. And you'll notice that that's a little over 3 times the length of a beam bridge. And multiple arches, so you can do one arch and then another arch. And sometimes we have different configurations of arches, which we'll take a look at. So there's the deck arch, where here's your roadway, and you drive on top of the arch bridge where you see the rainbow shape. The portal bridge, it looks kind of like a beam bridge. Your intuition might tell you that, but these piers are not vertical, okay? It's kind of like we chop the top of that arch off. Then we have a through arch bridge, where this is our roadway. The arch provides support here. These are not cables, okay? Those are solid members. And then the half through arch bridge, where you start driving on top of the arch, and then you go underneath it, and you end up back on top of the arch. And here's some examples. So who has ever, where's this one? I'll show it. You are, you should not be going to downtown. Lander. Yeah, that's the one on the way to Carson, yeah? Holds a silly record. What about this one? Nice. Completed. We see that arch shape, okay? In all of these pictures, we see that rainbow shape. That is an arch bridge. So this is not real, sorry. But here we have our arch shape going over the top of it. Here's a good example of what engineers actually do. Okay, this is the design. They come up, they prototype, so someone actually designed this, and it has to get drawn and designed before it's actually implemented. So this, I think they're proposing to put this in Dubai. Is that your notes, Bill, or something?
I didn't put it in there, but yeah,
Dubai.
Alright, so next we're going to talk about suspension and cable stay bridges. So suspension bridges can span the furthest out of all types of bridges, and they can go up to 7,000 feet, which is over a mile. Cable stay is a little bit shorter and can only go up to 3,000 feet, but both bridges are supported by steel cables. So now we're actually going to talk about the difference. So first we have suspension bridge, and the suspension bridge has a main suspension cable that's very, very strong. And from that suspension cable, we have smaller cables that actually attach to the road surface, and this is actually going to create a U-shape. So a good example is the Golden Gate Bridge. So as you guys can see, we have a big U from one pier to another with that main suspension cable, and then you can actually kind of see all of the smaller cables attaching to the roadway. And they're actually very, very thick. They're made out of smaller steel cables wrapped up to make one big one, so they're about 3 feet in diameter. And then next we have cable stay bridges, and these cables connect directly to the roadway from the pier, so it's actually going to create an A shape. So this is the bridge that we saw in the opening slide, and so you guys can actually see the triangular or A shape that it connects from the piers.
Next we have a truss bridge, which is the strongest type of bridge. It also takes up the most amount of material to make. These pieces that we put a truss bridge together with are called members, and these members, the idea behind having a lot of members is that it's easier to lift up an object or hold up an object with a group of people, a team with members, than it is to do by yourself. So we'll see a picture here, and you notice a triangle shape going throughout the entire thing. So what is heavier than a car or a bus or even a semi that we might want to drive on a bridge? Tony,
Monster truck.
how many monster trucks?
1,000 of them.
No. Huh?
An elephant.
An elephant?
A tree.
Full of bricks.
A brick truck, yeah. That's actually what I was thinking. A train. So we use these for trains a lot. We don't use them in applications where we could use less material, okay? So this, you can see there's a lot of steel here. It does hold up a lot of weight, but if we don't need to use up that much material, we won't, because it'll actually cost less to use a different type of bridge. And there's, we didn't bring kits today, did we?
Mm-mm.
So, what you need to do to explain some of these kits is, there's these joints, you guys see these? To those of you who are colorblind, forget I mentioned colors, but purple and blue, you have to show them how to make those connections. You tell them that the string goes on last. Purple and blue connections, purple and purple connections on the big bridge kits. What you need to do is you need to make sure that they're doing purple and purple between the two piers. There's piers on the outside, and sometimes kids use those blue pieces in the middle and it doesn't work. And they're like, I don't have enough pieces. You're like, no, you're wrong. You just used them in the wrong spot. Something